let's take a look at some special right triangles. So this image was taken from the reference chart that you would see whenever you're taking an exam over special right triangles. And what we're looking at is a 30, 60, 90 triangle and a 45, 45, 90 triangle. On the 30, 60, 90 triangle, all you need to know is one side, and it doesn't matter which side. It's easiest if you can have the side that's opposite from the 30-degree angle. So you would label that side as X, and then the side opposite from the 60-degree angle is going to be X times the square root of 3. And then the hypotenuse, which is opposite from the 90-degree angle, is going to be 2 times x. So if you have any one of these sides, you can fill in the missing information pretty easily. So I'm just going to give you a quick, easy example. So let's say, for example, I know that the side opposite from the 30-degree angle is 2. Well, then to find the side opposite from the 60-degree angle, I would do 2 multiplied by the square root of 3. And then the hypotenuse is going to be 2 times 2. So that gives me 4. Now the 45, 45, 90 triangle, in my opinion, is easier to look at. So, for example, if you know that the leg is some number, then you can easily solve for the other leg since they're going to be congruent because it's an isosceles right triangle. And then the hypotenuse, all you do is you take whatever the length of the leg is and you multiply by the square root of 2. So if we look at an easy example right here, let's say that I have a leg, and these are both 45-degree angles. Let's say that I have a leg that is 3 units long. Well, then the other leg, since they're going to be the same length, since they are opposite of the same degree angle, this is also going to be 3. And then the hypotenuse would just be the length of the leg multiplied by the square root of 2. Let's look at some more examples. So let's look at this 45, 45, 90 in the picture that I have. I have the length of one of the legs to be 2. Because it's an isosceles right triangle, the other leg has to be congruent. So in this picture, A would also equal 2, since it would be the same length. And then the hypotenuse, which is opposite from the 90-degree angle, is going to be the length of the side times the square root of 2. So you would just multiply this side right here of 2 times the square root of 2. And that gives you the hypotenuse. So basically you're just filling in the missing information. And then here's a 30, 60, 90 triangle example. So on this one, what's given to you is the hypotenuse, and you know that because it's directly across from the 90-degree angle. And you know that the hypotenuse is going to be 2 multiplied by x, where x represents the length of the side that's opposite from the 30-degree angle. And then the length of the side that's opposite from the 60-degree angle would be x multiplied by the square root of 3. So since I know the hypotenuse is 8, if I want to solve this equation for x, to isolate the variable, we can just divide both sides by 2 to get 4. So the length of the side opposite from the 30-degree angle is 4. And then to find the length of the side opposite from the 60-degree angle, all you would do is do 4 times the square root of 3. So that gives you the other 2 legs on the right triangle. Let me go over 2 challenging questions for special right triangles, and you'll see in a second why these are a little bit more difficult to do. So on the first one, this is an example with the 45, 45, 90. So the reason why this one's challenging is because the side that's given to you is the hypotenuse. And the hypotenuse, if you look at the picture, is a whole number. We know that the hypotenuse is going to be equal to the length of the leg, x, times the square root of 2. So we can just use algebra to isolate the variable to solve for the length of the side. So what I would do is I would want to divide by the square root of 2. And instead of leaving our answer like that, where you have a square root in the denominator, we want to multiply by the number 1 in a creative way. So we're going to multiply by the number 1 because we're not changing the value of the number. So if we multiply by the square root of 2 divided by the square root of 2, that allows us to eliminate the square root in the denominator. So now this becomes 16 times the square root of 2, but in our denominator we have the number 2. The square root of 2 times the square root of 2 basically cancels out the square root, and it leaves you with the number 2. And then we can simplify here. 16 divided by 2 is 8, so that gives us 8 root 2. So that would be the length of the side x. Now let's look at this other question. So this one is for a 30, 60, 90 triangle. So on the 30, 60, 90 triangle, we're given the length of the side that is opposite from the 60-degree angle. And we know that the length of the side opposite from the 60-degree angle is going to be the measure of the side opposite from the 30-degree angle times the square root of 3. So we're using the same process as what I just went over on the 45, 45, 90. So to solve, and actually I'm going to go ahead and list this variable as variable y, because in my picture I have the side opposite from the 30-degree angle as y. So I'll go ahead and list that as the variable y. So we have 15 is equal to y times the square root of 3. So then to solve, we would do 15 divided by the square root of 3. And just like I showed you, we're going to multiply by the number 1 in a creative way. So we're going to multiply by the square root of 3 in the numerator and the square root of 3 in the denominator. That becomes 15 times the square root of 3, and then in the denominator we just have the number 3. And now we can easily simplify by 3 to get 5 square root 3. So y is equal to 5 times the square root of 3. Let me write that a little bit nicer. So y equals 5 times the square root of 3. Okay, now to solve for the hypotenuse. The hypotenuse is going to be equal to the side of the 30-degree angle times 2. So I'm going to say that that's equal, x is equal to 2 times y. And we just solved for y. So I'm going to replace this variable with 5 root 3. So 2 times 5 is 10. So then the length of the hypotenuse in this picture would be 10 times the square root of 3. I hope these questions and examples were helpful to you.